Hi guys, today we're going to take a look at lesson 75, area of a complex figure and area of a trapezoid. And so far we've practiced finding areas of figures that can be divided into two or more rectangles. So shapes that kind of look like this, where we could say, oh yeah, if I cut this into two pieces, I can find the area of both. Well, now we're going to do this with triangular regions as well. So let's get started. And you guys know the formulas for all of them, so it shouldn't be a problem. So here's a interesting little figure. You can see, basically see you have a rectangle right here, okay, and then you have a little bit of a triangle left over, okay. So I'm going to go ahead and divide it into two pieces so we can look at it. Okay, so it's the same figure. I split it into two. I have the rectangle and I have the triangle. And I know that this is 10 and they told me this was 3. So I know they're parallel and they're equal. So that meant this piece was 7, which means the part of the triangle that we took off was 7. And we knew this whole stretch over here was 16. They told us that was 16. And the top was 8, which means to about right here is 8. The other half also has to be 8. So there's where I get my other base, okay? All right, so we go about this just finding the area of the rectangle and the area of the triangle, and we add them together, okay? So here we go. Two formulas. Rectangle is area is length times width, and the triangle area equals base times height over 2. So I'll reveal this one first. So area equals 10 times 8 millimeters, so we get 80 millimeters squared for the rectangle. And then over here we show the area equals 8 millimeters times 7 divided by 2, so we should end up with 56 millimeters squared divided by 2. But it wants the whole figure, so then we have to add them together. So then I have to show this step here, 80 millimeters plus 28 millimeters squared, sorry, equals 108 millimeters squared, okay? All right, so here's the next figure. It's kind of an interesting figure. This one starts off, you don't know this piece, but you can imagine it looks like somebody cut a corner of a paper off. So we're gonna draw it back in because sometimes it's easiest to find the area of a larger figure and then subtract the tiny part, which is what we'll have to do. Okay, so that requires us to know this whole rectangle, and then we have to figure out the triangle and we have to subtract that piece. Okay, so let me scooch my paper up. All right, so we start off with the area of the rectangle. Area equals length times width. Okay, so I have length right here, or I could do length 10 times 10. So that's an easy one. Area equals 100 centimeters squared. And then the triangle, same formula, base times height over 2. Okay, and how did I know the edges? So I know this whole thing is 10 from here to here, and they told me this was 3, so I know by subtraction that must mean this is 7. And I did the same thing here. From here to here is 10, so I just subtract and I knew that that was 3. Okay, so base times height over 2. I should have 3 centimeters times 7 centimeters divided by 2. Gives me 21 centimeters squared divided by 2. And that's 10.5 centimeters squared. So then to find the total, I'm not adding them together. I have to subtract. I have to take the big figure, subtract the triangle portion. So I should come up with 89.5 centimeters squared. Okay, and I encourage you guys to hit pause along the video and try and solve it yourself. That really is how you're going to gain kind of mastery in this area. Okay, so going on, so those are the complex figures. Now we're going to take a look at the trapezoid. All right, so, sorry, I make you dizzy here. I want to talk to you a little bit about the trapezoid. If we look at it, we can take a basic trapezoid, and if we extended the edges, it looks like a rectangle. And we know that the area of a parallelogram, which could be a rectangle, has 2 pairs of parallel sides. That's a parallelogram. We would normally do length times width, or we could say base times height, normally, Okay, well, in this instance, we only have one pair of parallel sides. Okay, this is a little side talk here, so don't panic. You're welcome to write it down. If I were to do the basic parallelogram area equals base times height, if I multiplied it by the base down here times height, well, that would give me too much area, okay? Because let's say this is 10 times 10, or 10 times 5, that would be 50, but look, I'm missing some pieces here. But if I multiplied it by, let's say, base 1 times the height, my answer would be too small because it's a misshapen figure. So the reasoning, you'll see on the formula, what they do is they find the average of the two bases, and that's where we get our formula from. So if we average them, we actually get the best of an area that's too big and an area that's too small. So we remember parallelogram, base times height, but we take the average of the two bases times the height for a trapezoid. So what it looks like is area equals, you add the two bases together, which gets you a base amount, and you multiply it by the height and you divide by 2, which is an average, okay? Or, this is our actual formula, 1/2 times base 1 plus base 2 times the height. And that, what that means is it's taking an average of the two bases and multiplying it by the height. Okay, so that's where the formula comes from. So let's take a second. Here's your formula. Area equals 1/2 base 1 plus base 2 times the height, where base 1 is the top parallel piece, base 2 is the bottom one, and the height is the tallest point in the trapezoid. It's perpendicular stretched all the way down to the bottom to make a right angle. So we've practiced this before. It's from the tallest point to the bottom. It has to be perpendicular, okay? All right, so 1/2 times base 1 plus base 2 times height. Okay, so here's what it looks like. So if I have a trapezoid like this, I notice that base 1, this top piece, is 10 centimeters. Base 2 is 7, and the height is 5. So we just plug in the numbers into the formula. So here we go. Here's our formula. Area equals 1/2 base 1 plus base 2 times height. And yes, you have to write it every time. Area equals 1/2 times 10 centimeters plus 7 centimeters times 5 centimeters. And remember, PEMDAS, order of operations, says do what's in parentheses first. So we get 1/2 times 17 centimeters times 5. You start to see where we get the centimeters squared. Okay, why is this not centimeters squared? Well, we're just adding, we're not multiplying. Okay, it's like 1 plus 2, okay? Then we get 1/2 times 85 centimeters squared. And we're taking half of it, so that could also be written as 85 divided by 2. It's the same thing. Okay, we're finding that average. And we get area equals 42.5 centimeters squared. So I want you to hit pause and look at the next problem, okay? And it says estimate. And before we begin, I want you to think about, if you had a ruler, where the halfway point would be. Because if we're counting numbers 1 through 10, we say 5 and up, round up. And if it's below 5, you leave it the same, okay, or round down. Well, in a ruler, the halfway point is not 5, it's actually 6 inches. Okay, so 5 feet, 11 inches. Is that closer to 6 feet on a ruler or closer to 5 feet? And you should automatically be thinking, oh, it's closer to 6. I'm almost 6 feet along. Okay, this one, 7 feet, 2 inches. The halfway point would be 6 inches, so we are closer to 7. And 10 feet, 1 inches, we're closer to 10 on the ruler, okay? So be thoughtful about that if they're asking you measurements. So estimate the area of this trapezoid. And I'd like you to try it yourself, okay? Oh, there's our base. Okay, so base 1 is 6 feet, base 2 is 10, and the height is 7. We decided, okay? So write out your formula. Oh, sorry, there's 6 and up, round up, 5 and down, round down. That's on a ruler, not normal. Okay, so write out your formula, hit pause, take a second to solve the problem. Okay, so here we go. Area equals 1/2 times 6 feet plus 10 feet times 7 feet. Area equals 1/2 times 16 feet times 7 feet. Okay, area equals 1/2 112 feet squared. And you should have come up with 56 feet squared. Can you do 1/2 times 16 first? Absolutely. In fact, order of operations says in multiplication, yeah, you would work left to right. So you could have had up here 8 feet. Whatever you do here, you would end up with like 8 feet times 7 feet. You'd still get 56. Okay, and if you choose to do this base 1 plus base 2 times height over 2, I won't fault you. It's the same thing. Okay, so you're going to hit pause and you're going to do the practice set, and then I'm going to go through the answers with you, and I really want you to do that practice set on your own first. Okay, don't skimp. Make sure you draw out the figures. I think there's only 3, and label the pieces as you go. Okay, here we go. So you have this little figure they gave you, and they didn't tell you, I think I'm going to go back and look at it. Hold on just a second. Okay, so the part that they did not tell you was the 4 and the 4. Okay, so we had to figure that out. We knew that this was 12, and we knew from here to here is 8, because that's what here to here is. Okay, so that left us with 4, and we knew from here to here is 10, and there's 6, so that left us with 4. Okay, so that's what I'm working with. This is a complex figure. It is not a trapezoid, so we're going to find the rectangle, and we're going to find the triangle, and we're going to add them together. Okay, so I go through area for the rectangle. Length times width, 10 times 8, I get 80 centimeters squared. Triangle, base times height over 2. 4 times 4 divided by 2. 16 centimeters squared divided by 2, and I get 8 centimeters squared, and then I don't forget to add them together. Okay, so I come over here and I say 80 centimeters squared plus 8 gives me 88 centimeters squared. Okay, second one is this figure. Okay, and there's a couple ways you can figure it. You could have done what we did earlier, where you find the whole thing and you subtract this triangle. This one was handy. I went ahead and just dropped a height right there. Okay, and I figured it out. So there's more than one way to do this. I will not fault you either way. Length times width for the rectangle, I get 12 times 10 and 120 centimeters squared. And then for the triangle, area equals, I did 1/2 base times height that time, but it's the same as base times height over 2, same formula. Area equals, you plug in the 9 and the 12. Okay, and you might be wondering, where did I get the 9? I come back over here. I know from here to here is 10, and from here to here is 19. So if I turn this into a rectangle, that would be 10, and this would be 9. And I knew that was 12 because it's parallel to this side, okay? All right, so I get area equals 1/2 times 108 centimeters squared and 54, and my grand total would be 120 plus 54 centimeters squared. If you did the subtraction route, you'll still get the same answer. Okay, if you found the whole shape and then subtracted this triangle right here, that's okay. All right, so then our trapezoid, here we go. The trapezoid looks like this. We can see that the base, the first base is 20, the second base is 12, and the height is 15. So we have to find the average of the two bases and multiply it by the height, okay? So we write out our formula. Area equals 1/2 base 1 plus base 2 times height. And I plug in the numbers I have. Area equals 1/2 times 32 centimeters. Why is it not centimeters squared? Because we're adding, we're not multiplying. Times 15. I should get area equals 1/2 480 centimeters squared. And then area equals 240 centimeters squared. Okay, so then the last problem was a challenge problem, and I did not do D. It says write the equation for the area of a trapezoid. We've been writing it this whole time, so it's this up here, okay? All right, but for D, they're saying if you laid a math book on the table and it had certain dimensions, they wanted you to estimate it. Well, the dimensions they gave you would round to 3 inches for base 1, 5 inches for base 2, and they told you 3 inches for the height. So it's just a standard problem, okay? And yeah, I know these are getting long, but it's the way it is. You're gonna need to be working towards algebra style, and every problem takes about 5 lines. So if you're giving me less than that, you're probably not gonna get full credit for showing your work, okay? All right, so message me with any questions, or if you're feeling stumped, or if you want me to go over anything, that's fine, okay?